in this we are actually doing 8F, which is carboxylic acid. So I'm here right now. This should finish today. It's a small portion, it's not very big. And once I finish carboxylic acid, the next one I said is the esters. So this is where we are currently in your syllabus. Okay. Last time what we finished was um, we studied about alcohols, how to make them, how to make ethanol, reactions of ethanol, and so on. Now, so what we are understanding is, what is this carboxylic acid? So this is another organic class of homologous series of another organic group of compounds. So first of all, they have now a quick review. The functional group in alkenes was CC double bond. Alkanes don't have any functional group. Then when it comes to alcohols, the functional group present was OH group. You might remember we named them as methanol, ethanol, and then we said propane 1-ol, propane 2-ol, butane 1-ol, butane 2-ol, and so on. That was alcohol. They have OH as functional group. Carboxylic acids. Now I'm sure you eat a lot of fruits. There are so many sour candies, all the fizzy drinks, most of them. I mean, they're of course carbonic acid, but most of the fruits, the vinegar that you use in the noodles and you mix it up, they all comes under carboxylic acids. All of these are organic acids, they are weak acids. So first of all, what kind of functional group they have? So they have COOH as functional group.
Manipulation.
Beg your pardon? Someone has a doubt? Okay, just make sure your mics are kept switched off and only use it when you have to. So they have COOH as functional group. Now this is the display formula of that. Of course, it can be written as a different way. And this bond that I make here, that's the empty bond. Okay, so that's the empty bond with which it is going to connect to somebody. Okay, so that's the empty bond. So I can write this as COOH, and don't be surprised if you see this somewhere. It is also the same thing. Okay, so this is usually how we write it in the structural formula, and that's the display formula. I'm sure you remember what is display formula means. You open up all the bonds and so on. Okay, so this is first point. That's the functional group of carboxylic acid. Anywhere you see COOH, that's the carboxylic acid. The second point is they are weak organic acids. Okay, first of all, the word weak acid. Do you remember the definition of a weak acid? A strong acid ionizes completely. When it comes to a weak acid, it means they ionize partially. They don't ionize fully. Okay, they don't release too many H plus ions. Remember, acids are proton donors. So these guys, they don't. That's the reason why you are able to eat fruits. That's the reason why you're able to have vinegar. You add vinegar in your noodles when you have them, because you can't be doing that with a strong acid. You can only do that with a weak acid. So they are very weak acids. They are called organic acids, and they ionize partially. I'm going to give you some equations to show you that in a short while. And now let's have a look at how do we name them. So this is the naming format. Now for alcohols, I taught you how do we name them. I said alkane dash all, and the dash was the position of OH group when at least there are 3 or more than 3 carbon atoms. That was how we used to name alcohol. So we used to say methanol, ethanol, because there are ethanol on 2 carbons. The moment you say prop, 3 carbon, you have to say propane 1-ol, propane 2-ol. When you go for 4 carbon, you have to say butane 1-ol, butane 2-ol. That was how alcohol was named. If you remember naming of alkenes, I taught you alk dash ene. What that means is Again, the position of the double bond only comes when there are at least 4 carbon atoms. There is no methane, so you say ethene, then you say propene if there are 3 carbons. But if there are 4 carbon, you say but1ene and but2ene, so on. So everyone has a naming format. So carboxylic also has a naming format. The naming format for carboxylic acid is we count the number of carbon and we say alkane. How many other carbons are there? If it's 1 carbon, we say methane, 2 carbon ethane, 3 carbon propane, 4 carbon butane. So we count the carbon, we say alkane, and we end the name with oic acid. So the naming of carboxylic is alkanoic acid. So when you see oic acid, that's how you come to know it's a carboxylic acid. Yes, the word dissociate is also perfectly fine. Absolutely fine. Ionize or dissociate. Sorry, as this word. Okay. Now, for example, there is a general formula mentioned. Now remember, everybody has a general formula. So I'm just going to write some comment here. You might remember CnH2n plus 2. This was the general formula of alkanes. You might remember CnH2n. This was the general formula of alkenes. And then CnH2n plus 1 OH. CnH2n plus 1 OH. This was the general formula of alcohol. So everybody has a general formula. N was the number of carbon atom. With the help of general formula, you could figure out the molecular formulas very quickly. And you're always supposed to memorize this. You should not forget this. So general formula of carboxylic acid, the one that you can use, CnH2nO2. This is a simplified general formula, and I will show you how best to use it. So for example, okay, so let me go to the next page and I'll give you some examples how to write the molecular formula, how to draw the display formula, structure formula, and how to name carboxylic acid. So that's the first thing that we're going to do. If you're ready, if you have any questions anytime, let me know. So that's the first example. If n equals to 1, remember n means the number of carbon atoms. So if n equals to 1, so that's the general formula I have, right? CnH2nO2. Would you like to type it in the Zoom chat and tell me what do you think could be the formula there? What could be the formula? Just put the value of n as 1. So that will be C. 1 we don't write. 2 times 1 is 2. So CnH2, CH2 and O2. That's the molecular formula. Is that okay? Molecular formula of the carboxylic acid which has only 1 carbon. Now let's make display formula. When I say display formula, it actually means sometimes when you see the question, draw the structure. So when they say like that, so you're supposed to open up what is called as a display formula. So remember I said carboxylic acid, they look like this COOH. That's the carboxylic acid full display formula there. And for the sake of more better clarity, keep the carboxylic on the right hand side. Start from right to left. So this is my first carbon. Obviously I have to make carboxylic acid. So this is my first carbon. But now I only have total 1 carbon, and that carbon is already finished. I have only 1 carbon here, that's finished. So what do I put here on the left hand side? I cannot keep the this one blank. Now if you look at the formula, I have 2 hydrogens there. So that's how you come to know 1 hydrogen is here, so 1 must be here. So this is the display formula of this. Now once you have the display formula, you should be able to convert this into structural formula. So when they say convert this into structural formula, so how do you do that? So structure formula just means, just copy down as it is, don't show any bonds in between. So just say HCOOH, that's it, and you're done. And then they'll ask you, okay, so what do you think is the name of this compound? Now don't forget the naming format I gave you. alkane oic acid. Alkane oic acid. This is how we used to name them. So would you want to try? You could use the mic or you could type in. What could you say is the name of this compound? It has only one carbon. Very good. Well done. So it's only one carbon. So remember meth, eth, prop, bute. You should never forget these. Meth, eth, prop, bute, pent, hex. You should never forget these. Okay, so that's one carbon, two carbon, three carbon, four carbon, five carbon, and six carbon. All the time you must always remember this. So I have only one carbon, but I have to say alkane. So I'm going to say methane. Methane. And remove the E and put oic acid. So it becomes methanoic acid. Okay. At this point of time, do you have any questions? If you have no questions, could you please type NQ in the Zoom chat? No questions? Everything is okay. Okay, then let's try n equals to 2. If you have some, if you're writing on a paper or in a book, so go ahead. Why don't you try this out for me? So n equals to 2. Don't say the answer in the Zoom chat yet. Just give yourself a few seconds. So figure out the molecular formula. So that's the molecular formula here. That is the display formula. I'm just going to use short forms now. That's the structural formula. Okay, so go ahead and give me the molecular formula, and then let's try to figure out the display formula, and then we'll figure out the structure formula and the name. Direct questions you will get in the exams. You will be expected to draw them out. These are popular exam areas. Okay, so let me know if anyone needs any help, or type done if you think you have the answers either on the paper or in your mind. Apply the general formula which is mentioned here. Let me know if you have the answers. Nadine, any help required? Guys, I would love to see everybody's
Sure.
names. Yep, sorry. You got it? You're okay?
Yes.
Okay,
Yes,
great.
sir. Good.
Okay, great. So just check the answers and let me know if anyone needs. Please let me know, okay? So the molecular formula you should have got was C2H4O2. Please let me know if you need help. As I said, keep the carboxylic on your right hand side. I'm not saying that you cannot keep it on your left, but it makes more sense to go from right to left for carboxylic acid. I'm not saying you can't keep it on the left, but you probably won't see it in most of your textbooks or resources. And then, so that's the first carbon there, starting from the right side. And this carbon, don't forget, every carbon needs a total of 4 bonds. So you could just check, I have 2 carbons, 4 hydrogens, and 2 oxygens. Your structure formula should be looking like this. There is no need to put the bond, like for example, if anyone has done like this, I'm not saying it's wrong, it's perfectly fine. Okay, but usually we don't show the bond in between, so you could just leave that. And how do we name this? I have 2 carbons. Remember, 2 carbon is eth. So you say eth, but you say ethane. So you write ane also. Remove the E and put oic acid. So a diluted solution of ethanoic acid is vinegar. That's the one that you are more familiar with. Does anyone has any questions for me? If you're feeling strong and if you're feeling like, okay, I got this, why don't you very quickly try for n equals to 3 and n equals to 4. You only have to go till there. So if you have any something to work on, why don't you go ahead, n equals to 3 and n equals to 4. And you can match the answers as I write. Okay. So if n equals to 3, so you go ahead, molecular formula, display formula, structural formula, and the name. Let me know when you're ready. Just type done in the Zoom chat if you think you got everything. And if anyone needs help, please let me know immediately. Remember, the general formula is CnH2nO2. That's the general formula there. That's what you're going to use. Remember, the carboxylic acid, the functional group looks like this. And as I said, let's go from right to left. That carbon is the carbon number 1. That's the boss carbon. It's always at the first position. So I think you got the molecular formula correct by now. You probably would have got C3H6O2. Is that okay? Give me yes or no. Everyone is okay with it? Expect direct questions in the exams. Display formula, because it's a 3 carbon. Okay, so don't forget what I keep telling you. Carbon number 1 is this. I'm just putting the numbers here for you. So you kind of number from right to left. You don't have to put the numbers in the exams, but this is only for my teaching purposes. And so the first carbon is your, as I said, that's the boss carbon there, carbon of the carboxylic. You always show that as carbon number 1. So second carbon, remember each carbon is supposed to have a total of 4 bonds. So you just keep counting 1, 2, 3, 4. Every carbon needs 4 bonds there. So that's the display formula. The structure formula is you just take the display formula and just crunch it. So that's a CH3, and then there's a CH2 and COOH. That's it, nice and easy. And how do we name it? Now I have a 3 carbon situation, so I'm just going to say propane oic acid, and we're done. Any questions? Everyone is okay? But the syllabus says you must go up to at least 4 carbons, so why don't we quickly finish the last one here? So if n equals to 4, you go ahead, type done when you finish. Let me know when you're okay or when you're finished. I need the molecular formula, display, structural, and the name. Okay, so the molecular formula which you should have got, I think, let's try to finish this fast. So the molecular formula would have been C4H8O2. This would be the display formula. That's the carbon number 1, that's the carbon number 2, that's the carbon number 3. Remember, we are going from right to left, and that's the carbon number 4. That's the display formula. Structure formula, CH3, CH2, CH2, COOH, and it's a 4 carbon, so you will say butane oic acid. That's it, nice and easy, all done. Okay, I'm pausing for a few seconds. If you have any questions on how do we draw them, how do we name them, how to do like the numbering of carbon is, as I said, right to left and so on. If you have no questions, we'll move on to our next topic. Everybody's okay? Could you just give me a Y for yes in the Zoom chat if you're okay? Everyone, please. Thank you for guys who are typing in. Okay. A couple of kids are missing the session today. Anyway, I'll figure out a way. Okay, so if everyone is okay, our next heading, we're going to do some reactions. Now remember, it's carboxylic acid. Although it's a weak acid, but it will do the reactions of what an acid does. Okay, so what the next heading is, reactions of carboxylic acid. Once again, let's make it very clear that they are weak acid. Okay, I think just for safe, because I'm pretty sure this question will be there in your past papers. Remember, we said weak acids are the one who can dissociate partially. Okay, so first of all, I'm just going to write a opening comment regarding their dissociation. So let's see how to write what is called as a dissociation reaction. Okay, in case they ask you to show by an example, and usually the acid they are going to talk about is the one and only ethanoic acid, but of course you should be prepared for other acids as well. Now in the previous page here, you already know the first four acids. So remember, the first one is meth, so that's methanoic acid. Particularly, my advice to you is that you should be very clear with the structural formula. So that's the structural formula of the methanoic acid. Then that was the structural formula of the we did methanoic acid, we did ethanoic acid here. So please stay focused on the structural formula, and that's the structural formula of the propanoic acid, that's the structural formula of butanoic acid. So whenever you write equations of carboxylic, my advice to you, please use structural formula. Please do not use molecular formula until and unless the question clearly tells you that please use molecular formula to write this equation, which they very rarely do, but they do. I have seen it. However, generally when they say write an equation, please stick to structure formula. So let's say I want to write a dissociation equation for this acid. Now you should literally know this is methanoic acid. Okay, so remember, you're almost getting into your senior classes. You shouldn't fumble with the formulas. Your formulas has to be absolutely perfect. So that's the methanoic acid. Remember, it's a weak acid. So if it's a weak acid, this is very important for you. This is an indication that the dissociation is not going complete. It's partially. In fact, to be very honest with you, out of 100, if I was to give you 100 methanoic acid, maybe 5 to 7 approximately will only break. So we are talking of about 5% dissociation. Most of the acid actually doesn't dissociate. Now what happens here is this hydrogen here, that's the one which is going to be kicked out. No other hydrogen goes out. So that's the one which is going to be kicked out as a H plus. Okay, so that's the H plus that you notice here. Now once you kick this H as a H plus, whatever else is left, that is HCOO negative, that becomes one negative because H went out with one plus, whatever is left is one negative, and this is called methanoate ion. Okay, let's practice a couple of more equations to show this is how a dissociation reaction looks like of a carboxylic acid. It has a very distinct reversible sign in between. If you forget this in the exam and if you write a single arrow, I can assure you that you will lose the marks there. Okay, so don't be very careful. Anytime you deal with a weak, you have to use reversible sign. Now remember, ethanoic acid. So what is ethanoic acid? CH3COOH. Now, do you want to do this? Ethanoic acid. Now, you know how it works. So you will make me the reversible sign first of all. And don't forget, it is this hydrogen, not the hydrogen connected to the carbon. It's that hydrogen which is going to get kicked out. Okay, this H goes out. And this will come out as a H plus. So that's the proton. Acids are proton donors. Don't forget. And now what is left? This entire mango tree which is left here, we just literally copy paste that. Now the logic that you are going to use, that somebody went out with a one positive charge, so whatever mango tree is left will have the reciprocal, the one negative reciprocal charge. In fact, that's how you figure out what could be the charge of this one. Okay, now that's ethanoic acid. Now from the hint which I wrote here, this is methanoate ion, so you could guess what could be the name of this one then. So this is ethane OAT, OAT, ethanoate ion. Okay, so that's the dissociation of methanoic acid, ethanoic acid, and you could do by yourself now propanoic acid as a last example here. So again, it's very important that you don't fumble on the formulas. Okay, we are not expecting you to do that. Make sure that the formulas are perfectly written. and so the H comes out as an H plus, and what is left, the entire thing which is left here, you just literally copy paste that, CH3, CH2, COO, don't forget the negative. If that's propanoic acid, so this must be propane OAT, OATE, propanoid ion, and that's it. So this is how we write the dissociation equations for carboxylic acid. I'm waiting for your questions. Let me know if I can help you with anything, or if you don't have any questions, could you please write NQ so I can move on to my next page. The most important thing, to make sure that the reversible sign is there, to understand if the H comes out as H plus, what will be the thing which is left. Everybody looks to be okay. Fantastic. Okay, great. So that was the first set of equation, dissociation reaction. And now remember, being an acid, your syllabus says you should be able to react this with, let me check, with metals and with metal carbonates. Okay, good. So reaction with metals. Now I'm going to write something, and I want you to explain to me if you think you're comfortable on that. Reaction with active metals. Now, why did I say active metals? Why couldn't I just say metals? Anyone would like to use the mic? Like, what was the need for me to say that? Anyone wants to try? What kind of acids are carboxylic? They are weak acids, right? So that's the issue. They don't kind of react with everybody. First of all, they cannot react with metals who are below hydrogen, right? So let me put that here. This is important to remember. No reaction, in fact, not only carboxylic, anything, no reaction of acids with metals below H in reactivity series. So don't forget that. Below hydrogen, any metal who may exist, for example, who are the examples? Copper, Hg, Au, Ag, Pt. I hope you know who these are. This is mercury. This is gold, silver, and platinum. So none of these metals, Cu you already know, copper you already know. None of these metals can react with any acid, strong acid, weak acid, doesn't matter. These guys can't react. Okay, this is copper. So when I say active, it means I need metals which are a bit more reactive. That's correct, because already the acids are weak. So I need, that's a good answer there. So active means some kind of reactive metals there. So I wouldn't be taking the average reactive metals like Fe or zinc. It's not that they won't react, they will react, but for the sake of consideration, we always pick up the metals which are more reactive. Okay, so let's pick up some, I'm going to pick up two acids here. So this is my first acid, HCOH, and I'm reacting this with sodium. Sodium is a top reactive metal, correct? Now, the story here is what you would expect. Sodium is going to attack this H. This is the H who is going to get kicked out. This is displaced because sodium is more reactive than hydrogen, correct? So more reactive can displace the less reactive. Isn't that what you studied? Now, just now I showed you how to write dissociation equations. Now notice in that dissociation, the formation of methanoid ion. How did this ion come? When the H was lost as H plus, methanoid ion was there. Now I'm going to use that. So this HCOO negative. Now see, this is just, I'm writing here for your understanding. You understand that's a negative? You already know why it's negative, because H goes out as positive. Now what's the charge on sodium? Now you know from the periodic table, sodium is group 1. So it is +1. So could you guess what's going to happen? So the negative and the positive gets cancelled out. So this is how I come to know the formula of the salt. And another thing, did you notice? If I ask you, what is the formula of sodium chloride? What is your answer? You will say NaCl. You notice that the metal comes first and then the non-metal. But for organic salts, it's the opposite. The negative ion will come first and then the positive. Okay, the negative comes first and then the positive. Okay, so that's basically how this is going to be formed. Plus this H which has got kicked out is going to form H2. Now I can balance this equation two ways. To easiest for you to balance, I can just put here half. Are you familiar with this concept that I can use fractions? Give me yes or no. Everybody, could you please type Y for yes? Like, you understand that I can just put here half because hydrogen exists as H2. If I put half here, my equation is done. So if you don't like what I did, then you multiply the whole equation by 2. So either you can put here half or you can put here 2. So let me write it here. Or you can just put here 2. Your equation still is balanced. And remember, without balancing, you won't get the mark in the exam. So multiply the whole equation by 2. You will still, now you can write here H2. So either you can do this or you can do this. Both equations are perfectly correct. Now here you already studied, it's methanoid ion. So can you guess the name of this salt? So this is called sodium methanoate. So it's a salt. Because remember, acids plus metals gives us salt and hydrogen. So this is the reaction with sodium. Now this was our first reaction. Let's do another one. I'm going to use a different acid here. CH3COOH. So this is methanoic acid. And this is ethanoic acid. And I'm reacting this with sodium again. Do you want to try this? Why don't you try this and let me know? Type done if you think you're okay with the answer. Type done if you think you're okay with the answer. Once again, don't forget, when you write this equation, you can write with the fractions or without the fraction. If you want to remove the fraction, just multiply by 2. Type done if you have this equation in your head. How the reaction happens will be exactly the same. Sodium will come here, kick this poor hydrogen out. Of course, this is going to change into H2 because hydrogen exists as hydrogen. It's a diatomic molecule. So what should I get? I should get CH3COO. Now remember, this is CH3COO negative and Na is positive. So they will cancel out. So I should get here this plus I will get H2. Okay, now how do I balance this equation? Anyone has a suggestion? This is sodium ethanoate. Or do you think the equation is already balanced? The equation is not balanced because I have two hydrogens here. So it's going to be exactly the same way. So either I can put here half or I have to multiply by 2. Which one would you prefer? Which one would you prefer? Do you want me to put the fraction or can I just multiply by 2? What are you used for? Because two hydrogens are here, so I need to put here 2. This will become 2 and this will become 2. Okay? Alright, done. Now, to challenge yourself, you notice one thing, that I gave you two different acids, but I gave you the same metal whose valency was +1. Now, I'm going to give you two equations in which we are going to use a metal whose valency is 2+. Let's have a look at the same two acids reacting with calcium or magnesium. They are group 2. So let's have a look. This is reaction number 3. Reaction number 3, I want this for those of you who are actually already working. So why don't you go ahead and do this reaction with calcium. And I have here CH3COOH reacting with calcium. Point to be kept in mind, that calcium is in group 2 and it has 2 plus valency. Okay, so don't forget the rough work. I'm supposed to get HCOO negative and calcium is 2 plus. So were you able to figure out the formula of the salt now? So you understand what's happening? 2 will come here and 1 will go there, but 1 we don't write. So what's the formula of the salt? HCOO. Now if you write here 2, it looks weird. It looks as if this 2 is only for the oxygen, but it's actually not. It's for everybody. That's why we need to put here bracket. That's the calcium. Don't forget, this is the hydrogen which is going to get kicked out as usual. I will get here H2. Now you need to balance this equation. Anyone wants to have a quick look at balancing? This is called calcium methane OH. This is methanoic acid. So what should I do? You can use the mic. The easiest thing what you can do is to work with the bracket. Now there is a 2 underneath the bracket. Because there is a 2 underneath the bracket, I'm just going to put here 2 immediately. Now I'm going to count my hydrogen on the left hand side. Let's count the hydrogens on the left. I have 2 inside times 2. I have 4 hydrogens on my left. There are 2 hydrogens here times 2, that's 4. Now if I look here, I have 2 hydrogens here. See this one, I have 2 hydrogens there and 2 hydrogens here. So that's 4 hydrogens. So my hydrogens are okay, which means my oxygen should be okay. Anyone has any questions? Okay, so let me know if you have finished the second equation. If you're not writing, at least can you try this in your mind? So let me know if you're getting the formula of the salt correct. So same drama here. So I should get CH3COO negative, and I have here calcium 2 plus. So I know that 2 is going to come down here. 1 we ignore. So I have here CH3COO. Don't forget the bracket. 2 calcium plus H2. Same thing, I have 2 underneath the bracket, which means I need to put here 2 and balance the equation. I'm still waiting for you if you have any questions. So I'm done with reaction of carboxylic acid with metals. You don't have to do metal with +3. You only have to do +1 and +2. I give you first set of equations with +1, that is sodium. Second set of equations I gave you with calcium, which is 2 plus. Okay. On a scale of 0 to 10, could you just mention what's your comfort level so far? 10 means everything is okay, everything is fine. 0 means you don't know what I'm talking. Could you give me a scale of 0 to 10, please, in the Zoom chat? Okay. All right, thank you. Okay, so now the final one, we only have 3 things to do here. The first was the, of course, dissociation reaction. How do we do this? Then reaction with active metals, and now the third one is the reaction with metal carbonates. Okay, reaction with metal carbonate. Now, good to know that when it comes to carbonate, it is CO3 negative. So this is called carbonate. And good to know that HCO3 negative, this is called hydrogen carbonate. So the first thing what you have to do is to make sure that you're okay with the formula of these ions, because remember, if the ions formula are not correct, then your formulas of the compounds don't go correctly, then your equation goes wrong, and then all that hard work goes to waste. Okay, so you need to be very clear with this. So that's the formula of carbonate, and that is also called as hydrogen carbonate. Sometimes some people will call it bicarbonate. So bicarbonate and hydrogen carbonate are the same thing. So I need to give you some example of metal carbonate first. Let's get some examples there, and then we'll get to the equations. Okay, so can we just do some examples of metal carbonate? Let's do it in an organized way. Metal carbonate. Okay, for example, if I have sodium ion and carbonate ion, can you work out the formula of these carbonates, please? And if I have the calcium ion and the carbonate ion, can you work out the formula of the ionic compound? And then if I have the aluminium ion and the carbonate ion. Okay, go ahead, let me know. And if I have the ammonium and the carbonate. So what I'm asking you to do is, first of all, get me the formula of these carbonates. I've already told you which ions I need. So if I have sodium ion and carbonate ion, does that make sense to you that it will be Na2CO3? Please give me yes or no. Like, is there anyone who's struggling that that's sodium carbonate? That's how formula comes. Everyone is okay. So calcium carbonate. So how does that work? Calcium carbonate. So the 2 plus and the 2 minus gets cancelled out, isn't it? So what's the formula of calcium carbonate? It's CaCO3. It's CaCO3. Okay, what about aluminium carbonate? Now what happens? So the 3 has to come here and the 2 has to come here. So the formula of aluminium carbonate is Al2, and then you put the CO3 in the bracket and put here 3. That's aluminium carbonate. Ammonium carbonate. So I have the 2 coming down here, but 1, of course, we just ignore it, as I said. So ammonium carbonate. So I have NH4, and then you put the bracket, put that 2 there, and then that's the carbonate there. Okay, I'm still waiting for you to tell me if any one of you has any doubts how to get example of metal carbonate. Are you okay so far? No, nobody has a problem. Okay, so these were some examples of metal carbonate. Now I'm going to give you examples of metal hydrogen carbonate, because first of all, get the formula of the carbonate correct, because if that goes wrong, then everything, your equation goes wrong, everything goes wrong. So first, let's be familiar with the carbonates. Let's have a look at a few examples of metal hydrogen carbonate. The worst mistake in chemistry is with respect to formulas. Okay, hydrogen carbonate. Remember, hydrogen carbonate is HCO3 negative. Now, for example, if I have a sodium, I have HCO3 negative. So you guys can start working on it. So let's say I have magnesium 2 plus and HCO3 negative. Then I have aluminium, which is 3 plus, member of group 3, HCO3 negative. And then I have here ammonium 1 plus, and that's the hydrogen carbonate there. Okay, let me know if you have the answers ready, and if I have the Fe3 plus and the HCO3 negative, and the Fe2 plus and the HCO3 negative. Okay, are you able to work this out? So if you look at the sodium ion and the carbonate, they have +1 and -1, so they get cancelled out. So what you get is NaHCO3, sodium hydrogen carbonate. For magnesium, so it's going to become Mg. Don't forget the 2 comes here, it comes below. So that's why it becomes MgHCO3 twice. So that's the magnesium hydrogen carbonate. Aluminium, once again, the 3 comes below this one. 1 we just ignored it. So AlHCO3 3 times. Ammonium, and they cancel out each other. So that is NH4HCO3 done. This one is FeHCO3. Don't forget the bracket and the 3, because this 3 so everybody. Now there's one more thing. You must be able to name this correctly. So this is called as iron 3. hydrogen carbonate. Now, why did I use the 3 in the Roman numeral in the bracket? Because iron is a transition metal. Remember, we do this for transition metal. We don't do this for everybody. Okay. Similarly, this one comes out as FeHCO3 twice. So we call this as iron 2 once again because it's a transition metal. So I have to put that oxidation number there. Iron 2 hydrogen carbonate. Okay. So this was the all the carbonates and the hydrogen carbonates that you are supposed to know. So far, any questions? Pause for a few seconds. First of all, you know who your carbonates are. So these are called metal carbonates and these are called metal hydrogen carbonates. Anyone has any questions so far? Or could you just mention if you have questions or you don't have any questions? Everyone's okay? All right. Now, anytime we do a reaction of anybody, I mean, I should have written the rules here as well. Reaction with active metals. So the rule says salt plus hydrogen formed. So that was the rule. That was the rule if the acids react with metal. So there has to be a rule here as well. So the rule here says whenever the carboxylic acids, in fact any acids, but since we are talking of carboxylic acids plus metal carbonates, it doesn't matter which one, it could be carbonates or hydrogen carbonate, will form salt plus water plus carbon dioxide. That's it. That's the rule. So you get 3 things now. You get salt plus water plus CO2. So we're going to follow this rule and we'll develop all the equations. I've already taught you how to make the salt, which means it's exactly the same thing. Remember the salt, which is the positive ion and the negative ion. Salt, water and CO2, you already know the formulas. So the challenge only is to check the balancing of the equation and that's it. Let's have a look at our fancy those two acids again. So I'm going to take HCOOH. You already know who this is. This is methanoic acid. And this one here is the CH3COOH, ethanoic acid. Okay, so let's do the first 2 reactions with a metal carbonate. So I'm taking somebody with the +1, which is the sodium carbonate, Na2CO3, and I'm taking here somebody with +2, which is magnesium carbonate. So it doesn't matter which one I have taken. Okay, so do you want to give a few seconds to yourself and see if you can finish this equation? Type done if you think you have the answer. Just if you're not writing it, at least try to do it in your mind as well. So how do I get the formula of the salt? Don't forget I gave you the rough work for it. So this is HCOO negative and I have here Na plus. So how do I get the formula of the salt? I will get, remember, the negative ion must come first, not the positive. Guys, please be careful. If you write the sodium first, teacher will give you 0 straight away. So that's the salt here, correct? This is sodium methanoate. So this is the only challenging part. Rest you already know water will be formed. You already know CO2 will be formed. Khalas. And because CO2 is going to be formed, observation, you can say bubbles or you can say fizzing or you could say effervescence. Effervescence. Okay, same thing with acid plus metals. Hydrogen comes out as same. Okay, I need the balancing. Is it balanced? My sodium is not balanced. I have 2 sodium here. I have only 1 sodium here. So I need to put here 2. But if I put here 2, then this whole thing has to be, so I have to put here 2 to balance that one. Now, can we just check the carbons? I have 2 carbons here, 1 carbon here, that's 3. I have 2 carbons here, 1 carbon, 3. Okay, carbon is okay. Now let's check the hydrogen. 2 hydrogen into 2, 4. I have 2 hydrogens here, 2 hydrogens here. Okay, everything looks to be good. Okay, let's have a look at the second equation. So remember, I have CH3COO negative, and I have magnesium with a 2 plus charge. Magnesium is a 2 plus charge. Now what? So what formula will I get? CH3COO 2. Because I already taught you just now a few pages before. Remember, this 2 has to come here like this. And this 2 is for everybody, not just for the oxygen. Plus, I'm supposed to get the H2O, plus I'm supposed to get the CO2. Okay, now let's see the balancing. The fastest way to balance, because I can see there is a 2 underneath that bracket, which means I need 2 of this. So I'm just going to put here 2. And then I'm going to check my magnesium. My metal looks to be okay. But now I will check my carbons just to make sure they are okay. I have 2 carbons here. I have 2 carbons here. 2 times 2 is 4. I have 1 carbon here. That's 5. 5 carbons total. Now, if I look at this, I have 2 carbons here. Remember, this 2 is for, inside there are 2 carbons. Inside there are 2 carbons and there's 2 outside. So 2 times 2, 4. And there is a carbon here. So my carbons are perfectly balanced. Now, similarly, I have to check if my hydrogen is balanced. I have how many hydrogens here? I have 4 hydrogens there. 4 into 2, I have 8 hydrogens. Okay, let's check here. I have 3 here and 2 here. So that's 6 hydrogen. And I have 2 hydrogens. So my H is okay. If my H is okay, my oxygen is okay. And don't forget, this is called magnesium ethane O8. Okay, waiting for your questions as of now. Is everyone okay? I gave you an equation with +1, sodium is +1. I gave an equation with +2. Don't worry about the +3, they won't ask. Is everyone okay with it? Okay, good. So now this is the last part of the chapter. Interesting. So this is the last part of the chapter. Something about, I was speaking about vinegar today, right? So I said vinegar comes from carboxylic acids. So just remember a comment. Vinegar. First of all, let me just write the formula here. CH3COOH. This is ethanoic acid, correct? Okay. Now, aqueous solution of it. Now, what does that mean? It means when it is dissolved in water. Aqueous solution, okay, of ethanoic acid. So basically think of this as you put extra water in it. So aqueous solution of ethanoic acid is called vinegar. So the syllabus says you should know what vinegar is made up of, where it's coming from. So it's obviously it's like a diluted solution of ethanoic acid. So think of that way. Okay, so that's the end of this particular chapter. Do you have any questions for me as of now? Are you sure there's no questions? So very quickly, let's see what all we did. Carboxylic acid, we understood the functional group. How do we name them? That's the general formula. How do we write the molecular formula, structure formula, display formula? All done. Everything done here. We did some dissociation equation. They're weak acids. That's why the reversible sign is there. We understood how to write the names and the formula of the ions. And then with metals, we applied that concept to understand how do we name the salts and how to balance those equations. So, okay, guys, I'm still
Sir, I have a
waiting for you.
question.
Yes, please.
If it's if it's a strong acid, is it still going to be reversible?
No. Strong acids you wouldn't show as a reversible reaction. If I, for example, if I'm going to do HCl plus sodium, let's say, so I'm going to use that. But if I'm going to do CH3, COH, so usually the reversible sign is associated with anybody who's weak, not strong. It's an indication that the reaction is not going to completion. So that the moment we write, of course, it also means it's reversible, but the fact that it's not going to completion, that means there is a forward and a backward reaction happening. Is that okay? Okay. Are you sure there's no questions as of now? Looks to be okay. The next lesson is supposed to be esters. So let's discuss the options. So what would you like me to go ahead? I mean, would you like me to do it now, or do you want me to keep it as a 1 hour session for today? And I'll take the new lesson when I see you next in the in-person class. What would be your choice? Your call. Would you want me to start the next chapter, or you just want to take this chapter? We just have two small chapters left to finish the entire portion. So next class I can finish the complete esters, and maximum 2 sessions I need to finish your entire portion, and then we only do past papers.